So in this question here, we've got a car towing a trailer up a hill, and I've started the diagram here. So the car, there's the tow rope, there's the trailer, and theta is the angle of the hill. Now, what we're given here is the car has a mass of 1350 kilos. So what we can do is, as we go through this information, we'll fill in the forces diagram and finish it off. So the car has a mass of 1350 kilos, so therefore the force acting on that is gravity. So the gravitational force will be going in this direction, and it's 1350, which is the mass of the car, times the gravitational constant, which we've got here. I'm just going to fill that in as G. So that's the first bit of information taken care of. So that's done. So now the trailer has a mass of 650 kilos. So we can fill that in, same principle. Gravity is acting on the trailer, 650 is the mass and the gravitational constant. Next we've got the car engine pulls at 7,700 newtons. For the purpose of this question, these three pieces of information here are all constant. Otherwise, it would not be the correct answer. If that's changing, we won't have the correct answer. So the car engine pulls at 7,700 newtons. So if the engine's pulling, it's wanting to take the car up the hill. So therefore, that is acting up the hill 7,700 newtons. So that takes care of that. Next, the drag on the car, so that's the air resistance and stuff, is 230 newtons. Now the drag is trying to bring the car backwards because it's trying to stop it. So therefore, the drag is acting on the car in this direction. And same again with the trailer, 150 newtons. It's trying to slow the trailer down. So it's going in this direction, 150 newtons. Okay, now a couple of other bits of information we're going to need on here is the car is travelling up the hill, so it's accelerating up the hill because that's part of the question. We need to find the tension in the tow rope and the acceleration of the car. So that brings us on nicely to the acceleration is going in this direction, it's going up the hill. Now we need the tension in the rope. Now as the car is towing this trailer, it's quite a heavy trailer, it's trying to bring the car back. So the tension in the rope for the car is going away from the travel of direction. But the tow rope is bringing the trailer along, so the tow rope in the trailer is going in this direction because it's trying to push the car along, push the trailer along to keep with the car. Okay, now next thing we're going to need is what other forces? Well, on the trailer and the car we have the normal force. Now that is going up parallel to the plane that is driving along. Now the normal force then in this direction will be going over here. So that's the normal force. Now what we need here, as the car is not leaving the road, it's staying flat on the road, it's not lifting or increasing in height or anything, this normal force here and this force in this direction, they are equal. So this will also be the same as the normal force. The two forces will be the same. So that's using Newton's third law. Every force has an equal and opposite reaction. So that's what we're interested in here. Now also with the car accelerating, we need to remember Newton's second law, where we use force is mass times acceleration. That's going to be the key part of our answer. So let's work out what the forces are. So force is acting on, first of all, for the car. So for the car, let's resolve the forces going in this direction. So they are going away from the acceleration, so they will be negative. So we've got minus 230. We've got minus the tension. Then the force acting in this direction is 7,700 newtons. So we add 7,700. But we've also got the gravity of the car. As it's going uphill, the gravity is going in this direction. So therefore, when we sum of that force, we'll be going down the hill. So we need to work out what that is. So that's going to be equal. If we draw a line parallel using these lines here, there will be a line going along here, which will make a right angle. Now the angle inside here, that corresponds to this theta, but with the angle at the top here, that one is theta. So we need to know the force going along on this line here, parallel to the plane. Well, to know if it's sine or cosine, we know it's going to be opposite the theta. So opposite angles, we use sine. So therefore, we need to go in this direction, so it's against the traveller direction. So minus sine, and this line here is going to be the same as sine of theta equals opposite over hypotenuse. Now the hypotenuse we know is 1350g, so sine theta times 1350g. So that's all the forces acting in the parallel to the plane. Now force equals mass times acceleration. Now the mass is 1350 and acceleration we don't know, so that's what we're going to put in there. So next we have a look at the trailer. So similar kind of thing happening. What's going in this direction? Well, here we've got 150 newtons, so minus 150. Tension in the rope is going up the hill, so that's a positive. Then the force acting on it is just from the car, so we don't know what that is yet. That's all coming from the tension in the rope, so that'll be included in the tension. And then we've got this one here, where we did same as here. This time our sine theta multiplied by 1350g. This time is 650g. But this time it's also going in the negative direction, so we need to subtract again. So minus sine theta times 650g. And then as its force equals mass times acceleration is 650a. Okay. So now we need to find tension and acceleration. So we've got a classic situation. Two variables, two unknowns, two equations. So treat it like a simultaneous equation. So first of all, these are different values, quite awkward, but these are -1 and +1 coefficients. So if I add them together, they will disappear, and then I'll be left with acceleration on its own. So let's do that. So let's add the two components. So add, I'll put a big add sign. Right, minus 230 plus 7,700. Well, 7,700, that gives me 7470. So I've got 7470. And here I've got minus 150. So I'll do minus 150. T's cancel out. That's great news. And then I've got these sine thetas with 1350 and 650. So therefore I can subtract. If I add these two numbers here, 1350 and 650, that gives me 2000g. 2000g sine theta. And then here, if I add these two together, I'm going to also have 2000 and the variable a. Okay, so now let's see if we can fill this in a bit more. So 7470 minus 150, that's 7320. Minus 2000g, so that's minus 2000 times 9.8 sine theta. Now what is sine theta? Well, we're given cosine theta is root 15 over 4. So let's do a little right angled triangle and see if we can find out what sine theta is. Right, cosine is adjacent over hypotenuse. So hypotenuse will be 4, adjacent root 15. Sine is opposite over hypotenuse. So what would this side be? Well, if I square this and subtract it from this one squared, well, left over will give me that. So therefore this side is just going to be 1. So that takes care of that. So I've got 2000 times 9.8 times a quarter equals 2000a. So now I've just got numbers here, I've got an a here, so divide this side by 2000, I'll get a on its own. So now acceleration equals 7320 minus, let's do some simplification before we plug it into the calculator. 2000 divided by 4 is 500. 500 times 9.8, or 5 times 9.8 is 49. So basically what I've got here is 4,900. and then that equals, sorry, not equals, you can divide that by 2000. So we can simplify off a little bit, take that off, take that off, take that off, divide everyone by 10, that's legitimate. 732 minus 490, that gives me 242 over 200, which equals 121 over 100, which equals 1.21. So therefore, acceleration is 1.21 meters per second. So that equals 1.21 meters per second, and that's squared. So now we've got acceleration, we can just go back into here and find our tension. So this one looks the easiest one. So minus 150. So minus 150 plus t minus sine theta, which we worked out was a quarter. So minus a quarter, and that's going to be multiplied by 650g. So multiplied by 650 times g is 9.8. That's our gravitational constant. And it equals 650 times our acceleration, which was 1.21. So let's get t on its own. If we leave this on this side, I've now got t equals 650 times 1.21. Let's get the calculator and work that out. 650 times 1.21, 786.5. That's what that is. Then we need to add 150. That's coming over this side. And then add whatever this is. So 650 times 9.8 divided by 4, 1592.5. So let's work this out. 786.5 plus 150 plus 1592.5, and that's going to give me 2529. And the answer will be in newtons. So I've got 2529 newtons. So there we have our two answers to the question. Okay.